This topic is all about solving logarithmic equations where you have multiple logs and extra numbers floating about. So we just can't use the logical implication of, oh, the arguments must be the same. In order to do these types of problems, we have to remember the properties of logs. So recall that if you have a log of a multiplication problem, log of a product, you can split apart the multiplication problem into separate logs via addition. If you have a log of a division problem, you can split that apart, split the division problem that is, into individual logs via subtraction. And if you have a log of an exponential expression, you can take the inner exponent and move them out in front of the log as a coefficient. So these are the three properties of logs, and one of the things that we did with them is condense and expand expressions. It was in a previous topic, I forgot the number. But what we're actually going to utilize, or how we're going to utilize these properties, is in the opposite direction. We're actually going to utilize these properties from right to left, taking multiple logs and scrunching them up together. So for example, suppose I ask you to solve, log base 2 of 4x minus 6 plus log base 2 of 6 equaling log base 2 of 12. So I can't simply just say, this log and plus this argument plus this argument equals that argument. That doesn't work. That only works when you have individual one log equaling one log. Well, fortunately, according to the properties, we are able to squish this guy together as one. So that shouldn't be a problem for us. Well, according to the properties, the left side of the equation becomes log base 2 of, you just multiply them together, 6 times 4x minus 6 equals log base 2 of 12. And then you distribute 24x minus 36 equals log base 2 of 12. And now that we have one log equaling one log, we can go ahead and do the implication step of saying, oh, the arguments are the same. So then we can solve for x and get x equals 2. However, since our original problem contained more than one log, you need to check your answer. Let me just go ahead and fast forward it to you. I'll just tell you that this answer is good. So that's basically how you solve problems if you ever have multiple logs in a problem with numbers. Well, I guess this one didn't have any extraneous numbers. Let's just do an example where we did have some extra numbers floating about. Say I asked you to solve natural log of 3 minus 2x minus natural log of 2 equaling 1. So again, I don't like multiple logs, so what we're going to do is we're going to condense this guy down together as 1. Since he's subtracting, we can condense it down with division. And then now it becomes a single log equaling a single number problem. And the technique was to convert it into an exponential form. So what does this say? This says 1 is the exponent on base e that gives us an answer of 3 minus 2x over 2. And then you just go ahead and solve for x. Now remember, e is just a number. I think it's 2.712 something something something. Typically, when you're solving equations with e, you just leave it as its own thing. Leave it as a letter. Leave it as a variable. So to solve for x, I'd multiply both sides by 2. Let's go ahead and subtract the 3. And then divide out the negative 2. For all intents and purposes, that is the answer. I really don't like negatives in the denominator, so what I'll do is I'll go ahead and distribute this negative into the numerator, and that's going to give us negative 2e plus 3 all over 2. Right. Technically, we're supposed to check our answers to make sure that the argument is not negative. When it comes to checking your answer, I'll go ahead and use a calculator. I would take my calculator, type this guy in, get a decimal approximation, and then just check it against the original problem to make sure that this whole guy is not negative or 0. But let me just go ahead and tell you right now, if you were to check it, this is a perfectly fine answer. Okay. Now, this is, like I said, I'd like the denominator to be positive, but if you were to give this as a final answer, I'd give you full credit. Just like with the other logarithmic equation types, the only way I can make this harder is to like change the stuff inside of it, change the argument. So maybe we don't have linear equations, but maybe we have, quadratics. For example, log base 6 of 4 plus log base 6 of 3x squared minus 3 equals 2. Okay, let's solve this. We can condense this guy down together. According to the properties, you go ahead and multiply the arguments. Let's just go ahead and distribute while we're here. So that's 12x squared minus 12 equals 2. Then you'll go ahead and exponentiate or rewrite it in exponential form. So what does this statement say? This statement says 2 is the exponent on 6. That gives us an answer of 12x squared minus 12. It's a quadratic equation, so, well, it is technically a quadratic equation, but notice how we only have one x term. So this is actually sort of a special case. Let's do 6 squared is 36. Remember that if you're solving a quadratic equation and you only have an x squared term, you don't need to use factoring. You can just use good old-fashioned algebra. Let's get the x by itself. So I'm not going to bring everything into one side. I'm actually going to add 12 to both sides. So that's 48 equals 12x squared. And then divide out the 12, because if you only have one x squared, if you only have one variable term, you can solve for it directly. To get rid of a square, you take a square root. But please remember, whenever you take a square root to solve an equation, your result will be plus or minus. Remember, this is two answers, a positive 2 and a negative 2. X equals 2, x equals negative 2. You have to check both answers separately. But let me just save you some time. If you were to check both answers, they're good answers. So that's about it. I mean, there are lots of different equation types that can come up from logarithmic equations with multiple logs and numbers, but ultimately the logic is the same. You want to bring all the logs together. You want to use properties to condense them down together, and then it should resemble previous equation types you've solved. So go ahead and give those a practice and see how well you do.